Hello, and in this video we're going to talk about how to implement frequency distributions and the calculations of their statistics using Excel. So let us assume we're going to have this scenario where we ask a sample of our city how many times they eat out at a restaurant per month. And let's assume the number of times that those people have ate out range from 0 to 16 and not outside this region. And let us assume the frequency of how many people ate out at this time is given in this column here. So the first thing that you may want to calculate is the sample size. So sample size. So the sample size is simply the sum of the frequencies. So you can have that as a formula if you need to. So the sample size is going to be the sum of the frequencies of x. So this is just going to be equal to the sum of the values given here from F9 to F25. So this is your sample size n. So I'll bold that here since that's important. Alright, so what is the next thing that you may want to calculate? So I may want to calculate the mean, right? So the mean, again, is calculated by this first formula here. So it's going to be the sum of the products of our values and the frequencies. So I'm going to go up here and create a column that's going to represent the value times its frequency. So I'm going to call that x times f of x. And I'm going to bold that center and give it another color. So this is just going to be equal to 0 times 1. This is going to be 1 times 1, 2 times 3, 3 times 2, 4 times 5, and so on. But I'm going to just click and drag this little box in the corner and click it down, and that's going to give me the products of each of these values. So I'm going to take those values, and I'm going to sum them up, and I'm going to divide by the sample size as I have in this equation. So it's going to be sum of all these products divided by the sample size, 190. So this is going to be what? So this is going to be the mean. So I'm going to put that in a more appropriate place. So the sum of the products divided by sample size. So this is the mean. Alright, so the next thing you may want to find is the median. Well, the median is not straightforward, and I don't want to sort of count and manually, okay, where is the half value of 191? So what is that equal to, actually? So what is half of 190 and 1? So that's going to be 95.5. So it's going to be in between the 95th and 96th value. So it's just going to be the average of those two values. So of course this is going to be the first value. This is going to be the second. This is going to be the third through the eighth, and so on. So I'm going to calculate a cumulative frequency. So this is going to be equal to the frequency here. So this is the first one. And this is going to be equal to that frequency plus that value. So it's the frequency of the second category plus that. So that's going to be 2. So that means after this first category, there has been 2 samples. So if I click this down, what do I get? So that means after these first 3 categories, there has been 5 values. Well, is that true? Well, here's the first, here's the second, here's the third, fourth, and fifth. Here's the 6th and 7th, so this next value should be 7 if everything is working appropriately. Then add 5 is going to give us 12, and that's going to give us our cumulative frequency. Right? And this last value means that throughout all of these categories, you should have 190 values, so this number and the sample size should correspond with one another. So the 95th and 96th values are located where? Well, up to this category, there's going to be 96 values, right? And the category before is going to be 78. So 96 is going to be the last value of 9. 95 is going to be the second to last value of 9. So that means the median is going to be equal to 9 based on that analysis. All right, so what do we have here? So we have the median is equal to 9, and the mean is equal to 9.38. So which is bigger? So that means what? So since the mean is bigger than median, then data is skewed to the left or right. So remember, if the median is bigger than the mean, it's skewed to the left. And if the mean is bigger than the median, then that means it's going to be skewed to the right. That means most of the data is going to be on the left. And we'll see that graphically in a minute. So now let's calculate the standard deviation. So I'm going to create another column here that I'm going to use to calculate things. I'm going to calculate the x minus mean squared values. Now, why do I want to do that? Well, according to this frequency distribution version of the standard deviation, I'm going to sum up all of the squared differences between the values and the means and multiply those squared differences by their frequencies. Alright, so for the first value, that's just going to be equal to the value minus the mean, which is here. And then I'm going to square that. Now remember, F29, the mean, is not going to change at all through this process. So I'm going to anchor this value by putting a $sign before and after the letter address of this. And then I'm just going to click and drag that down. And you can check to see if this last one makes sense. So this is going to be E25 minus the mean squared. Okay, that's good. Alright, so then I'm going to calculate, okay, well, what is the x minus x bar squared times f of x value? So this is going to be the values in the numerator of this standard deviation formula that we're going to add up. So we can just calculate this by taking the frequency and multiplying it by this x minus mean squared. And then I'm just going to click and drag that down. So what is the standard deviation equal to? Well, the standard deviation is just going to be the square root of the sum of these products divided by the sample size minus 1. And make sure you have the parentheses in all of the correct categories, in the correct locations. So we have 3.24748. So those are the actual most common important things you may want to find. You may want to find the mode or the quartiles or the interquartile range if you want to, but I'll just calculate these three and leave the others to you if you desire it. Alright, so the last thing you may want to do is maybe give a graph of the frequency distribution. So this is very easily done. I'm going to highlight these two columns, the values of interest and the frequency distribution. And make sure that this first column is going to be a numerical ordering of some sort. That is, that's going to give the primary difference between a frequency distribution and like a bar graph per se. So I'm going to go up here to Insert, and I'm going to go here to Insert Scatter, XY, or Bubble Chart option, and I'm going to click the first value that says Scatter Plot. So this is going to give me the frequency distribution. So therefore, I can give these appropriate titles if I really want to. And this is the number of times people eat out per month. And then I can start giving this graph some actual titles. So axis titles, primary, horizontal. This is going to be the number of times per month. And my vertical axis, so axis title, primary, vertical, is going to be what? Where'd it go? So that's going to be the number of times, or the frequency of answer. And that's pretty much a scatter plot or a frequency distribution graph. Now notice that the mean is bigger than the median, and that let us conclude that the data is skewed to the right, which means most of the data is on the left. But if you notice here, you may seem that, maybe it's equally balanced. And you can see that here, that the mean is approximately equal to the median. And if we even calculate the mode here, so how do you calculate the mode? Well, the mode is going to be the value in the number of times that has the highest frequency. So that's going to be equal to, according to this, is going to be 27. So that's 27 corresponds to 8. So notice that the mean and the median and the mode are approximately equal to the same, and we get this graph. Now the mode is slightly to the left of these. That's why you pretty much see this big hump more so on the right-hand side. But overall, there's about the same amount of people on both sides. And that's mainly due to the fact that the mean and the median are approximately equal to the same, and the mode is not that so far off. So it's maybe you can say it's approximately symmetric in terms of frequency distributions, but nonetheless, if we use this rule that mean bigger than median, then most of the data is skewed to the right. That's just a rule of thumb, not always practical, especially if these parameters are really close together. And that's an Excel summary and discussion of frequency distributions.